Hello there. I've got some more subnetting for you. No dramatic intro this time though. That was funny the first time. So in this one, we're going to have a look at Class A and Class B subnetting. Now the process is mostly the same, and we're going to be working in the second and the third octets though. That's where the difference really comes in. The conversion table we use as well for the binary to decimal will need to grow, at the very least to help us with the 2 to the power of whatever. If you're not following what I'm talking about, you might want to go watch the previous video on the subnetting. That should hopefully help quite a bit. Now, before we get stuck into the Class A and B, let's just revisit the formula from the previous video. The number of networks is going to be 2 to the power of n, where n is our new network bits that we're creating. The hosts will be 2 to the power of h, and whatever that is, we minus 2 because of that broadcast and network address we need to reserve. And the h bits will be all of the binary zeros left behind. Now we're going to get more than an octet's worth at the very least, depending on how we do our subnetting. But the one that needs a bit of extra attention this time is the increment, or the 2 to the power of I. So the increment, or 2 to the power of I, is going to be the host bits left behind in the octet where the mask ends. These will be the binary zeros that we left alone, but it's only in the octet where the masks end or where the binary 1 stops. And this is going to be very important with the second and third octets. But big emphasis is it's going to stop counting the binary zeros in the octet where the mask ends. It's not going to flow into the next octet. You'll see what I mean when we work our way through an example. So let's start out with Class B, where we're now going to have one extra octet available to us than we did in the previous video. So here's our conversion table, but like I said, it's going to have to grow because we're going to be working with more than 8 binary bits at a time in some cases. So let's make this new table. We're going to use the same method though to expand this table that we used to create it. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, rinse and repeat till we got to 128, right? Now this time we're actually going to go a bit further. 128 times 2 is 256. 256 times 2 is 512. 512 times 2 is 1024. 2048. 4096. 8192. 16,384. And 32,768. And the row above where our 2 to the power of numbers is going to be 2 to the 8, 2 to the 9, to the 10, to the 11, to the 12, to the 13, to the 14, and to the 15. So now we've got 16 binary bits that we could work with if we need to, and we've got the answers for 2 to the power of up to 15 without needing a calculator. Remember, in Network Plus, you're not going to get access to a calculator always. So let's start out with a 172.16.0.0 network. And let's aim for a minimum of 3,500 hosts per subnet, or 3,500. Now remember, this is a Class B network, so the class or subnet mask is 255.255.0.0. Okay, cool. We are going to follow the same steps as before though. Step 1, we're going to take the class or subnet mask and we're going to rewrite it in binary, which looks like this now, where the first 2 octets are all binary 1s, because remember that shortcut we got from the numbering systems video. 255 is 8 binary 1s. And we also know that 8 zeros is 0. So first and second octet will be 8 1s, third and fourth octet will be all zeros. Now remember, those ones that are already set or already part of the network bit, we can't touch those if it's already been set. So let's just mark it red so we know we can't mess with it. Now for step 2, start converting host bits to network bits. In other words, zeros to ones, working from left to right, and we'll check the results as we go along. This means we better put out a little formula here for the number of networks and the number of hosts until we figure out whether we've reached our goal or not. So first bit gets converted. I've marked it in blue so you can see it more easily. And now this is a new network bit, and everything left over is a host bit. So 2 to the 1, we've created 2 new networks because we've got 1 new network bit. And we've got 15 host bits or zeros left behind. So 2 to the power of 15 is 32,768 minus 2 gives us 32,766 hosts per network. Not where we want to get to. We want to get to 3,500, not 32,000. So let's try again. Let's move another bit over and see what happens. So now we've got 2 new network bits, and we've got only 14 host bits left behind. So 2 to the power of 2 gives me 4 new networks, and 2 to the power of 14 gives me 16,384 minus 2, which leaves me with 16,382 hosts per network. Much closer to the 3,500 goal, but I think we could do better. So let's try a third binary bit, where we're now going to have 3 new network bits and only 13 host bits now. If we plug those into our formula, 2 to the power of 3 gives us 8 new networks, and 2 to the 13 gives us 8,192 minus 2 leaves me with 8,190 hosts per network. Let's try another one. 4 new network bits, and only 12 host bits left behind. This means we're going to have 2 to the power of 4 networks, which is 16, and we're going to have 2 to the power of 12, which is 4,096 minus 2, leaving me with 4,094 hosts per network. Now I know that's as close as we're going to get, but you might still be getting used to subnetting and not be able to see the next step unless you work it out. If that's the case, cool. Let's take that next step and see what a step too far looks like. So if we go for a 5th binary bit, we've now got 5 new network bits and a remainder of 11 host bits. This means I've got 2 to the power of 5, or 32 networks, and I've got 2 to the power of 11, or 2,048 minus 2 gives me 2,046 hosts per network. Fell short of that goal. So now we know it's a step too far, we go back one. Let's do the next step, which is to work out the new subnet mask. So the first 2 octets didn't change, so they're still 255, 255. It's the 3rd and the 4th octet where we're going to have things possibly being different. Although, spoiler alert, we didn't get to the 4th octet, so that's actually going to be the same. So let's put the binary values in there. 4 binary 1s and 4 binary 0s for the 3rd octet, and 8 binary 0s for the 4th one. Let's go and plug that into our conversion table, working from right to left. So that gives me 1 under the 128, 1 under the 64, 1 under the 32, 1 under the 16, and 0 under the rest, which, if you add it all up, gives you 240. 128 plus 64 is 192, plus 32 gives me 224, plus 16 gives me 240. So that is going to be the value of the 3rd octet, which looks really weird, but trust me, it's correct. And it barely needs working out, but 8 binary 0s is equal to 0, which means the 4th octet to the subnet mask is a 0. Now, we also have CIDR notation, which we covered in the previous video, and all we're doing with CIDR is counting the total number of binary 1s in the mask and expressing it as a slash number. So we've got 8 1s in the first octet, we've got another 8 in the second, giving me 16, and then I've got 4 in the 3rd octet, giving me an extra 4, or 20 in total. Let's go and see what step 4 needs from us, which is to plot the new subnets in a table. For this, we need the increment. This is where it starts to get a bit tricky with class A and B. So the increment is 2 to the power of I, and those 4 zeros left behind in the 3rd octet are my increment bits, not the other 8 in the 4th octet. All of the zeros make up the host bit, but the increment stops where the octet, where the mask ends. I don't go beyond that dot. So our increment is going to be 2 to the power of 4, which is 16. Okay, now let's grab that table. It's 16 networks, so this is going to be pretty long. So first up, let's put the subnet number in the number column, 1 through to 16 will do. And then we're going to start with the first network address. And we start with what was given to us, 172.16.0.0. Now, remember the rule is to add the increment value to the octet we were working in, where the mask ended. Now, in this situation, that means we're going to be adding it to that 0 there. The 3rd digit, the 3rd octet. Not the 4th one, because that was class C in the last video, but the 3rd one here. So 0 plus 16 gives me 16. 16 plus 16 gives me 32. 32 plus 16 gives me 48. Plus 16 again gives me 64. Rinse and repeat until we get to the last one. But what we do here, 240 plus 16 gives me 256, which we know is not possible in IP version 4, but we let that mistake happen. Because if I go one network beyond the total number of networks I created, I should see a 256 somewhere, which helps as an error checking method. Very helpful in the exam for CompTIA Network Plus because you don't get access to a calculator. Plus, it helps us fill out the broadcast address as well. So you remember from the previous video, the broadcast address was look at the next network's address, that one over there, and subtract 1 from it. Now, if I subtract 1 from 172.168.16.0, what's going to happen is I'm going to be at 172.168.15.255. That will literally be one digit before that address. Then, if I subtract 1 again from the next network over here, which is 172.168.32.0, that puts me at 172.168.31.255. It's a bit weird, but I promise it is correct and you will get the hang of it eventually. We are subtracting 1 in binary, basically. Now, if we keep doing that, we will fill out this whole section for the broadcast addresses. And for the last one, if we said 172.16.256 minus 1, that takes me to 172.168.255.255. Fantastic. Now I can scratch out that mistake from earlier. Serves its purpose. It can go away now. So let's work out the valid host addresses. Now this time I'm just going to fill out the first valid host column, and then I'll do the last valid host column because I find it to be quicker and easier that way. It's my personal preference. But if you want to do each network one at a time, go for it, your call. But the first valid host address is very simple. Look at the current network address and add 1 to it. So the first one is 172.168.161. The second is 172.168.161. Then 172.168.321, 48.1, and I'm just going to fast forward this bit again. Now we can start working on the last valid host address, which is just like before. Look at the broadcast address of the current network and subtract 1 from it. So that leaves me with 172.168.15.254, 172.168.31.254, 47.254, and fast forward. Great stuff. We can now stick our subnet mask in here, which is 255.255.240.0, and side notation of /20. And we can also use these tables to keep track of where we're using these networks, which is very, very helpful. Now let's have a look at Class A. Class A is going to be a little bit crazy because the values are going to get really big when we extend this table. It's going to be 65,536 because that's 32,768 times 2. 131,072. 262,144, 524,288, 1,048,576, 2,097,152, 4,194,304, and 8,388,608. And then the exponents is 2 to the 16, the 17, 18, 19, 20, 21, 22, and 23. We're going to have to move this table left and right as we're going along because it's a really big address, but we'll cope. So let's take the 10 network and try and get a minimum of 2 million hosts per subnet. Remember, the 10 network is a class A, so it gets a classful subnet mask of 255.000. First step is to always convert it to binary, which gives us 8 ones, and the other 3 octets are all 8 zeros. And remember, what's already set to binary 1, we can't touch it. So let's mark them red so we don't mess with them. And now we can start converting host bits, or zeros, to network bits, or binary 1s, and we can check the results with our helpful little formula. So let's try the first one. If I convert the first host bit to a network bit, that gives me 1 new network bit, and the remaining 23 are host bits. So 2 to the 1 gives me 2 new networks, and 2 to the 23 minus 2 gives me 8,388,606 hosts per network. I think we could get closer to the 2 million goal. So let's try another network bit. Now I've got 2 new network bits, 22 host bits, which means 4 new networks and 4,194,302 hosts. I'm pretty sure we can get closer. In fact, I know we can. So let's do it. A third network bit, which means now I'm going to have 3 new network bits and only 21 host bits left over. 2 to the power of 3 means I've got 8 new networks, and 2 to the 21 minus 2 gives me 2,097,150. Okay, much closer. But if you're still in that stage where you want to go one step further and see if you've gone too far, let's go and do that then. Let's go and have a 4th new network bit. And leaves me with only 20 host bits. So 2 to the 4 is 16, and 2 to the 20 minus 2 leaves me with 1,048,574, which is way too few, so we've gone too far. Let's go back a step. This is where we want to be at. 3 new network bits with only 21 host bits left over. Great stuff. Let's go and see what our new subnet mask looks like. So the first octet stayed the same, it's 255. So the second, third, and fourth that we're going to have to look at. But we need the other side of this table. Now we can start looking at converting it into binary. So if we put the 111,000,000 under the conversion table, that leaves me with 128 plus 64 is 192, plus 32 is 224. So my second octet is 224. Then the other 2 octets, the third and the fourth, are all zeros. So it gives me with a 0 for the third and a 0 for the fourth octet. Great stuff. We also want to look at what is our cider notation, which we know is the count of binary ones. I've got 8 binary ones in the first octet, and another 3 in the second octet gives me a total of 11. So I can write the subnet mask as /11 as well in cider notation. Now we're going to go and plot the new subnets in a table, and for this we need an increment. And our increment is going to work out to be 2 to the power of I. And remember, the increment is only in the octet where the mask ends. It's not the entirety. So it's those 5 zeros left behind in the second octet that is my increment. The remainder makes up part of the host. So my increment is 2 to the 5, which is 32. And that's what we're going to be incrementing the second octet by, is by 32. So let's go to our handy dandy table and fill out numbers 1 through to 8 for the number of networks we created. And we're starting with a 10 network. 10.0.0.0. Always start with what was given to you. Now, this time we're working in the second octet. The reason being, that is the octet where the mask ends. And that's where we're going to add the increment now. So it's 0 plus 32, which will give me 32. 32 plus 32 is 64. Plus 32 is 96. 128. 160. 192. 224. 256. We let that little mistake happen. Now, broadcast address. For this first network's broadcast address, we look at the second network and we say -1. So if I say -1, that goes to 10.31.255.255. Then for the second network's broadcast address, it's 10.64.00 -1, which will be 63.255.255. It'll be 95.255.255, 10.127.255.255, and so on and so forth. Served its purpose, it can now go away. And we start with the first valid host address, which is always +1 to the network address. So it's 10.0.0.1 for the first network, 10.32.0.1 for the second, 10.64.0.1 for the third, and so on. For the last valid host address, it's the broadcast address of the current network, -1, which gives me 10.31.255.254, 10.63.255.254, and so on. We can now put the subnet mask in, which is 255.224.0.0, and the CIDR notation of it's 11. And same as before, we can keep track of where we're using these networks, building A, B, and C, for instance. Great stuff. Now, the final thing is you're going to sometimes see Class A and Class B subnetted to look like a Class C subnet mask, maybe even beyond. This is something that's done quite a lot in the industry, and you'll definitely see it in a lot of networking exams. So let's go and have a look at what they look like, and then we'll talk about why this can be useful. So first up, Class B with a /24. Let's have 172.168.0.0/24. Or basically 172.168.0.0 with a 255.255.255.0 subnet mask. If we use that little sneaky trick we used in the previous IP video, draw a line after the last 255, everything to the left is network, everything to the right is host. And this means I have got 8 additional network bits, which gives me 256 networks in total, extra, and 254 hosts per subnet, which is not unusual considering it's basically a Class C subnet mask. Cool, so quite a few subnets created there. You do quite a lot with 256 networks. Class A gets even crazier when you do this, because 10.0.0.0/24 or 10.0.0.0 with a 255.255.255.0 subnet mask will look like this, where the first 3 octets are network and the 4th octet is host. This gives me 65,536 new subnets and 254 usable hosts per subnet. That's great. Now, the reasons why this is done is Class A and Class B are really, really large. And that's fine for some environments like data centers or similarly large LAN networks. But it's generally too large for most ordinary networks that you'd find in the average office building, the average school, the average library, whatever. So by extending the subnet mask into the 2nd and the 3rd octet and making it like a Class C, we are now able to use the 2nd and 3rd octets for very interesting things. So for instance, I could have 10.something.something.0/24. I might use the 2nd octet for an OSPF area ID and the 3rd octet for a VLAN ID number. Now I know we haven't done OSPF or VLANs yet, but we will in a future video, and I'll come back and add a tag card thing top right corner that you can look at and jump through to those videos. But they can be very, very useful to network engineers, and that's one of my favorite use case scenarios for them. But the reason why I want to warn you about this is this can be very off-putting in the exam to see a 10 network or a 172.1.6 network, a Class A or a Class B network, using a Class C subnet mask, but ultimately it's just subnetting. So they're using that just to see who's comfortable with subnetting and who's not. And then if they really want to be nasty in an exam, not necessarily CompTIA Network Plus, but maybe a more advanced networking certification, they might do something like this, where they'll say 10.1.10.0/24. And if you read that too quickly, it's going to mess you around. So read carefully, slow down, and remember, subnetting applies all the time, and we can subnet a Class A network to even beyond Class C. So what we saw in the previous video where I showed you how to do subnetting with Class C, you could see that being done to Class A, resulting in a tremendously larger number of networks with fewer people in each network. But that is all you need to know about subnetting for Network Plus. It is a bit heavy, I will admit that, and if you're still getting to grips with that, it's okay. It takes time to get good at subnetting, and it takes time for the penny to drop sometimes. I know it did for me. If you want to go and check out someone else's methods for subnetting, go for it. I'm not going to discourage you. There's 1,001 ways to do this, and all of them are correct. It is a skill set you need to develop. At the very least, to troubleshoot and support badly configured IP addresses when subnetting has been done. Maybe even later on in your life to do full-on network design. But nonetheless, though, I'd like to say thank you for watching. And if you have any friends or family members or colleagues or peers that would be interested in Network Plus, don't be afraid to send them a share here. Otherwise, though, I'll catch you in the next video.